think we're making sound. Yes, the microphone is. Okay, I think we are live. Good evening, everyone. My name is Mike Jerry, coming to you from the eastern Mojave Desert in eastern California. And we got started on Friday night on the Cloudy Nights Observers Challenge, and didn't quite get finished with that. So tonight we are going to go and get it finished. So let me put that up. Okay, and I need to turn off the pretty little banner there. Doink. Okay. Now, from the other night, we did these top ones. We got all the way down to, we did M74. This is the last one we did, NGC 680, 678, and IC 167. We got those. I took a good final image of those after my laptop crashed, and I came back, recovered from that. And so tonight, to continue on, we're going to start with NGC 935. Okay, NGC 935. Let's see how our screen sizes are doing tonight. NGC 935. It's probably going to be somewhere like that. Okay, NGC 935. Doink. Where are we at? Okay, so we are going to be on well, it's going to be below Aries and Triangulum. Where is Jupiter? Is way up there. Where's Mars? I'm not seeing Mars. There's Mars. Okay, Mars is way down there. So we're way above Mars. So that's good, because I can see Mars, but not much below that. Okay, so let's go ahead and slew up there to that one. Okay. NGC 935. Do a quick plate solve to make sure we're in the right place. And it's complaining again that it doesn't have enough stars. Well, you can see it right up here. So we're very close. Let's bring that puppy right down into our view. There we are. Okay. And now we will start imaging on it. Okay. Start imaging on that. Let's bring the background music in so you guys have something to listen to. Well, okay, so NGC, what is it? 935? Yes. NGC 935. NGC 935. And IC 1801. Is the northern member of the pair, and IC 1801 is the southern. Wow. Not much being said. Wikipedia has, like, they're a pair of interacting galaxies. That's all that pretty much they have to say on that. Okay. Let's see what I can see what Brent says too. And they're tiny little suckers. Here, let's do that. Do that. Do this. Yeah, they're definitely little guys. Definitely little guys. These would be great targets for my mono camera, but which is more sensitive and higher resolution, but we got what we got. But you can see the two of them right in here, and hopefully as we get more subs in, we'll be able to okay, battery's running low. This is what happened to me the other night. I charged it up for a while until it was charged full, and then unplugged it, and the thing just went down. So tonight may just end up leaving it in. But in any event, let's see what Brent had anything to say. Nope. He just refers to the catalogs he found them in and where they are located in those catalogs. So. And Wikipedia does not have very much on it. They're very tiny little suckers, so hopefully we'll be able to pick up some detail. But oh, and I know one thing that will help is my enhancements. It will definitely help sharpen things up a bit. Let's see how we're doing. Yeah, I'm going to pick up push the stretch a little bit so you guys can see it a little bit better. Unfortunately, I don't have a whole lot of info on these guys. Not really sure why, but not a whole lot of info. Their Hubble pictures, of course, are very pretty, but in the area here. Let's get our ocular out. Synchronize that. Definitely a little small guy. Yeah, this is definitely a target for my 183. Smaller pixels would help a lot. The further in we zoom, the mushier it gets, but you can see definitely they're almost like 90 degrees to each other. One core here, one core here. And then these, of course, are foreground stars that are in our own galaxy. All these little dots here. These are all stars that are in the Milky Way, very much in the foreground. These galaxies are probably dozens of millions of light years away. If I can find something else on them. NGC 935. Yeah, Wikipedia. I already know Wikipedia doesn't have anything. Spiral galaxy. Between a computed distance of 133 and 187 million light years. Okay, so somewhere around 160 million light years, give or take. So they are quite a ways away. Actually, before I did that, I should have Wikipedia does have, not you, does have the picture here. I'm not sure why that's very blurry. Well, there you go. That's from the Spitzer Space Telescope. So there's the bright star there and these two interacting galaxies. Oh, come on. And so there it is live in the view. Just two galaxies right near each other. Interacting, colliding. The fun thing about colliding galaxies is, even though each galaxy consists of billions, if not tens of billions, if not hundreds of billions of stars in each one, when galaxies collide, there is so much distance between all of the stars within each of the galaxies. Galaxies are so massive that there's so much distance between all of the stars in all those hundreds of billions of stars in the galaxy that when two galaxies collide, it's actually extremely unlikely that any stars will actually collide with each other. The reason galaxies, when they collide, get all pulled apart is because their gravity wells just pull each other apart. The gravity from one interacts on the other, and they just kind of pull each other all out apart and all out of shape. And so, kind of interesting. And of course it happens over the course of hundreds of millions of years, so there's no time-lapse photography for that. We can do computer simulations that will show what happens over the course of that time, but it's really a pretty cool thing, pretty massive thing. So again, shown in their context, that's what these look like in the sky. They're just barely bigger than the stars that we see, the stars we see in the foreground here that are in the Milky Way. But clearly they are. You can see here you get some of the spiral. You can see some of the spiral, and this one has a spiral arm, and there's a dust lane, a dark lane there in that one. There's a dark lane there in that one. Oh, we just got photobombed by a satellite. So, given more time and certainly a higher resolution camera, we'd be able to see more, but given that we're using the color camera, this isn't too bad. I'm going to push the stretch a little bit more. Risk of making it grainy, but Two little interacting galaxies. Well, little. They're somewhere between, they're approximately 160 million light years away. So, the light that we're seeing from them left there 160 million years ago. So, they're probably not so little. One of them could even be, this one could even be bigger than the Milky Way for all we know. I'm sure somebody knows. I just can't seem to find it in any of the popular information sources about how big they actually are, but they're about 160 million light years away. That much seems to have, we seem to have established that. But okay, so that would be NGC 935 and IC 1801, or ARP 276. And there are those little guys. Two interacting, colliding galaxies that are going to spend the next millions of years ripping each other apart. Okay, now NGC 1499, the California Nebula. Let's close that. Let's close that. NGC 1499, California Nebula. Let's see, where are you? Where am I? Okay, so you're not too far away. Good. We don't need a meridian flip. We like that. Okay, yeah. Okay. Yeah. Alright. Well, let's see what we can see of that. As you can tell from, as Stellarium is already showing us, it's way bigger than my sensor. So we'll probably only be able to get pieces of it, but we can hopefully see some pretty color. Alright, let's roll. Okay, we are plate solved. So let's get started on our imaging. How did our guiding do there? Doing pretty good. Excellent. Okay, California Nebula. NGC 1499. California Nebula is an emission nebula located in the constellation Perseus. Its name comes from its resemblance to the outline of the U.S. state of California in long exposure photographs. It's almost 2.5 degrees long in the sky, and because of its very low surface brightness, it's extremely difficult to observe visually. It can be observed with a hydrogen alpha filter or a hydrogen beta filter in a rich field telescope under dark skies. It lies at a distance of about 1,000 light years from Earth. We'll see. We definitely can see something here. Let's do a color balance and then do that, and then we'll stretch the heck out of it, even though it'll make it a little grainy, so you guys can see something. So this is kind of the central part of it, sort of central California. You know, this is the middle part that we're looking at here. Any challenges? No. Well, let's see how much we can bring it out. This does look, this would look much nicer with my narrowband filter, especially because it's an emission nebula. But, and I've also, I'm also working on a, using a large Canon camera lens, a DSLR lens. About 30 years ago, my late wife bought a really big, expensive, top-of-the-line Canon 80 to 200 lens for her Canon camera. It's a f2.8, and I'm going to, I'm buying an adapter for it this week, and I'm going to hook it up to my Astro cameras, and it should be, instead of where this camera gives us about a 1 degree field of view, that one will be probably a little over 3 degrees field of view, 3 or 3.5, I think. So that, in this case, we would get the entire California nebula in that. And it's fast at f2.8. It's significantly faster than my imaging newt here. So for the same amount of time, like a 60-second exposure, it'll get about double the brightness, because f2.8 collects light just slightly over twice as fast as f4, since it's the square of the focal ratio that determines that. And so a project that I'm looking forward to play with, and the California Nebula would be a great target to play with that, and eventually, ultimately, do the use my narrowband filter on it too. But first, to just get it working, get it so that it focuses on things and whatnot. Alright, so you guys probably need to have this stretched. Let's do a color correction on it again. That looks good. Stretch it again. Give you a little more red. Give you a little more red. I have to wait to see on the live stream to see what how it looks as it comes across. I always have a second screen going so that I'm watching my own broadcast, so I can tell what you guys are seeing versus what I'm seeing, because they are different. The algorithms that are used to make the live stream go out efficiently and for everyone to be able to access it on all the different devices and all that sort of stuff, those algorithms are a bit lossy. There is some loss in the transmission, in the brightness and the colors, etc. So typically what I have to do is I have to overdrive the stretch and make it look kind of a little bit blown out and crappy on my screen so that it looks good on yours. So because of that, I always keep a second screen going to monitor the broadcast so that I can see what you guys are actually seeing, or at least close to it. But I think it's coming out pretty well. And with a narrowband filter, what a narrowband filter would do is eliminate 98% of the light spectrum. Stars are full spectrum objects. So basically it would eliminate 98% of the light from the stars, which means the bright stars, the bigger, brighter stars in here, would dim down much smaller, and the faint stars would simply disappear. And so it allows the nebula essentially to pop out, because everything else, the stars in particular, is being cut way, way back, even to the point of being invisible in the case of the fainter stars. So it really makes nebulae pop out and show up really nicely. But and hopefully when I get that Canon lens working with my cameras, this will be a prime target for that, and you'll get to see the whole thing, and it'll really jump out nice and strong. Scott Gridley, hi Scott. First time watching your live stream, thanks. I just got your 533 a couple weeks ago. Nice, I love mine. I have it paired with an AT102 ED, but my biggest question is exposure times. How did you center on 1 minute? How did I center on 1 minute? I guess experience. I guess trial and error. You know, seeing what, and it also varies with what object you're trying to see as well. So really, it's just you experiment. Different objects are going to want different exposure times. In this case, something like a faint emission nebula like this, it wants more time than something like a star cluster. If you're going after M13 or M15 or any bright globular clusters, or even M42, the very bright Orion Nebula, the really bright objects, the Andromeda Galaxy, the really bright objects and stuff like that, you're going to want less exposure time, or you're just going to blow it out. So it depends on the objects you're shooting. It depends on your optical train, the scope that you're using. In my case, I've got a 6-inch imaging newt, so compared to a 102 refractor, it's a bit of a light bucket, collects a lot more light, and it's going to be a lot faster too. Your focal ratio is going to determine as well how much exposure time you're going to need. If you use that 102 at its native focal length, and if you don't get a focal reducer for it, then it's probably going to be what, f7, f8, something like that. So if your scope is f8, we'll say, just to use a round number, which is double the focal ratio of my scope, then that means it will collect light 4 times slower than my scope does, because it's the square of the focal ratio that determines the speed at which you collect light. So your focal ratio is twice as slow, so you'll take 4 times the amount of time to collect the same amount of light. So what I see in a 60-second sub will take you 4-minute subs to collect approximately the same amount of light. And so, you know, you'll just experiment with it, and you'll probably end up getting a focal reducer. If you're going to be using it for EAA with that 533, especially with the 533, because at the long focal length, if you're at 700 or 800 or something focal length, your field of view with that 533 is going to be pretty small at that focal length. I'm at about 600 millimeters of focal length, and I'm at 1 degree by 1 degree. And so at 700 or 800, you're probably going to be down, you know, 0.6, 0.7 degrees, less than 3/4 of a degree square. But if you get a focal reducer, you have 2 benefits. Number one, it increases your field of view size, and number 2, it also speeds you up. So you'll go from an f8 to f6 or f5 or something, and so that will dramatically speed up how quickly your camera collects photons. And so you'll just play with it, you'll experiment with it. You can see, if you go onto Astrobin or one of the other sites where amateur astronomers collect and post their images, you can search by equipment. So you could search by your AT102 ED and see what people are capturing, and see what kind of exposure times they're using. And or just, you know, if you're on cloudy nights, you know, or Stargazers Lounge or any of the forums, you can always ask, and because lots of other people will have that scope or something darn similar to it. I mean, quite a few makers make the 102 ED. I mean, almost everything is just made in the same Chinese factory and relabeled anyway. So, you know, lots of people have it, and so you'll be able to get lots of advice on what other people who use that scope are doing. Yeah, so a 0.8 reducer, yeah. And so 0.8 reducer with at f7, so you're going to be with that'll be what, 0.56, 5.6, f5.5 or so. So that'll speed you up nicely and get you a much bigger field of view, which will help with the 533. So yeah, that will dramatically help you get a bigger field of view. which will be nice. Now, what you may find yourself doing ultimately, if you stick with refractors, is going to upgrading from the 533 to the 2600, which will give you, it's a much more expensive camera, no doubt, double the price, but it will give you a substantially bigger field of view through that refractor. So, you know, you'll play with it, you'll get it dialed in and figured out, and with some experience shooting different types of objects, you'll see what I mean. Some are going to want more exposure, some are going to want less. Now, what is your mount? And are you using guiding, or have you done, how much EAA have you done? Alright, so California, well, we got certainly the central coast portion of the California Nebula. Maybe we'll go up here. Maybe we'll go up here and shoot some of the more northern part of it. You know? Center on this little star right there and maybe shoot another north, just to catch another part of it. But it's popped out pretty nicely, I think. It's popped out pretty nicely, so let's just head up and do another portion of it. We don't have do another portion of it here. We don't have a ton of objects tonight because we're just finishing up the last few from the December challenge. Although I imagine we'll get some of the, well, I was going to say get some of the bigger, more exciting things, but Orion is still pretty darn low, so we may not get some of those for a little while. We'll have to see. No, I started talking about this. It's okay, so we said it's 1,000 light years from Earth. Its fluorescence is due to the excitation of the hydrogen beta line in the nebula by the nearby prodigiously energetic O7 star Xi Persei, also known as Menkib. Whoa, what am I doing? So this star here is what they think is illuminating this whole thing. It's basically causing this entire region to emit, which is why it's an emission nebula. Yeah, there we go. So nice start. So this will just be the NorCal part of the thing. We did the Central Coast already. And now we're kind of doing the NorCal part. They call it a prodigiously energetic star. By coincidence, the California Nebula transits in the zenith in central California as the latitude matches the declination of the object. Kind of fun. So 1,000 light years away. Ah, you're new. Okay. Good. Well, it's an exciting adventure, and yeah, it can be frustrating at times, but it's well worth it. You know, the incorporation of computers in astronomy, well, like the incorporation of computers in anything these days is inevitable, but the incorporation of computers in astronomy does definitely increase the level of complexity. But what you can see with a modern camera sensor versus what you can see with your eye through even a very large telescope, there's just no comparison. You know, within a few minutes being able to see these fine wispy details in the California Nebula, You know, it's just you couldn't even hope to see this stuff in a visual telescope. Well, you could see it, perhaps, but it would be very difficult, and it would be just fine, light gray wispiness. You'd be hard-pressed to see any color. It would take some true averted imagination to see that, to see any sort of color in it. I was just blown away. When I was a visual observer for most of my life, since my parents bought me my first rickety little Sears refractor when I was a teenager. I lived back in New Hampshire. Of course, back then, 40 years ago, it was much darker than it is now. And but I was hooked. I would go outside, freeze my butt off, but I was just hooked. I loved it. And so I've been a visual observer my whole life, and I've had my Dobbs, and I've had refractors, and I've had this and that. But when I put the first half-decent, half-baked camera in the eyepiece and saw what came across on my screen, it was a whole new quantum level for this hobby. Absolutely awesome what a camera can see. And while I'm not interested in spending hours and hours capturing data and hours post-processing gorgeous, pretty pictures of things like real astrophotographers do, EAA is just something that's absolutely, I love it. Using the camera to see the stuff that I've always wanted to see with my own eyes but could never see in color, even with decent-sized Dobbs. I had a 10-inch Dobb that actually I took around to the desert with me, and you know, you could see a lot of stuff, but everything was still faint and gray. There was still very little color to see in a Dobb that size without going to something much bigger, which then becomes just a pain and to haul around and, you know. But with even a small, simple setup, well, I say simple, a small setup, and a camera, you can see amazing stuff. In fact, what I should do while we're doing this here, I should show you my setup. So this is what I actually use. This is my 6-inch f4 imaging newt here, just a simple little inexpensive telescope that's on my Celestron Advanced VX mount. And the 533, the camera is stuck right on the focuser there, as you can see, and I'm sitting right here behind this laptop talking to you guys, and this is pretty much my setup. And so it's inexpensive, it's relatively simple in terms of, you know, it's not some big huge daub, but I mean, I can see far more color and far more detail in this image than I could see in even a Dobb 3 times the size of my scope. So I was just hooked. When I saw what a camera could do in an eyepiece in a telescope, I was just hooked. So here I am doing this now, and the beauty of capturing this stuff on a computer is that then it becomes easier to share. So it's nice to be able to live stream this stuff too. No, we just blew it. Okay. How are we doing on this? We're doing good on the guiding. Excellent. Excellent, excellent. Let's see, I grew up in New Jersey and had a JCPenney scope that I could see almost nothing from. Yeah, well, in New Jersey, that's probably got quite a bit of light pollution. And down there in the more central East Coast, there's a lot more humidity in the air and a lot poorer transparency, too. But I could see almost nothing. I moved to Lebanon, New Hampshire. Yep, that's going to get you more dark skies. and used that same 15-year-old scope for a few years and was hooked. Yep, that's what it was like for me when I grew up. I grew up a bit south of Lebanon, but yeah, same idea. Dark skies. There's no replacement for dark skies. You just can't beat it, which is why there's a sort of a saying amongst astronomers that your best astronomy investment is gasoline. But kids, work, and other things drew me away. COVID was my opportunity to get back, and I'm really getting into the imaging now. Really appreciate your, yeah, no problem. It's yeah, it's a lot of fun. I really do enjoy it. Something just binged on me here. What did I PhD? No, PhD's looking good. Something just pinged, I don't know. Don't know what. Power's good. It's all good. Okay. Somebody's making noise. But obviously it doesn't seem to be too urgent. Alright, let's push the stretch a bit more. Make it really pop. So unlike the galaxy we were just looking at before, this one is only 1,000 light years away, so this one obviously is inside the Milky Way, relatively close to us compared to 160 million light years away, where those two interacting galaxies were. Yeah, it's funny you should say COVID was your opportunity to get back in, because a lot of people got into home-based hobbies during that, huh? I mean, you couldn't buy astronomy gear for the last couple of years. You couldn't buy bicycles. You couldn't buy fishing gear. You couldn't buy, I mean, anything that was, you know, based on a home-based, lockdown-friendly hobby. You just could not get anything, any products for, because it was just outstripped. The whole market was just outstripped. So, yeah. Okay. Let's see what Brent has for us next. NGC 1491. All right. So, there's the end of the California Nebula. Let's do 1491. Based on the numbering, it sounds like it should be fairly close. Fossil Footprint Nebula. Okay. I'm intrigued. Don't know that I've ever shot this one before. Fossil Footprint Nebula. Yeah, looks like it's right there. But we'll do a quick plate solve to make sure and get it centered up. Yeah, now it's right in the middle. Okay. Have to say about it. Okay, never seen it, but it looks interesting. NGC 1491. 1. NGC 1491. Oops. That's not what I was supposed to do. It's a bright nebula in the constellation Perseus. Distance looks like it's about 10 or 11,000 light years away. All right. Look at that. And I've got it a bit overstretched here. Now let's back this off. Clean this up a little. Yeah, that's pretty nice. Stretch it back a little bit more. I was lucky to get my job relatively fast. Great visual observing for the last 15 months. Yeah. So you're still in Lebanon, I imagine. Fossil footprint. Intriguing. Definitely got some stuff down here as well. It's actually a whole, this is actually a whole area in here. You can see a bit of it here. But this is actually only the brightest of the core, really. It's actually a whole area here. That is, yeah, you can see it's a whole area in here. That's, stretch it a bit more. You guys have a better shot of seeing it. But it seems to be just a whole area in here of nebulosity. So like I can get away with more. You actually moved to central Mass a few years back. Still decent darkness, thankfully. Yeah, as long as the further west you go, the darker you're going to get. So, good for you. Growing up in south central New Hampshire, like I said 40 years ago, we had some nice darkness. But not anymore. Now it's probably at least Bortle 5 or 6 or something. Check my battery levels there. We're looking good. I wonder if this is... It's a hydrogen beta region, so again, this would be something that would respond well to narrowband filters and a lot more exposure time. Although the core is so bright that, I don't know, this thing is quite a contrast of of areas. It's a bit like the Great Orion Nebula, where the core is really bright, so bright that when we look at it, it looks like the middle star in Orion's sword, because it's a stellar nursery where new stars are being born. So it's extremely bright in the middle, and yet it goes out and out and out with more wispy gas and dust and things. And it's just amazing how big the thing is. And from outside to inside is a heck of a lot of difference in brightness. So having a camera with a lot of dynamic range really helps. Well, we had a little bit of a breeze, just a really light breeze while I was out here setting up. But thankfully it has completely dropped off and it's just a nice, calm, clear night. So, another good one. 2 out of 3 nights in a row. Good, some good stuff. So, that's yummy. I don't know that we're going to get more out of that surrounding area, though. It's pretty faint stuff. All right, Scott. Say hi when you come back in. Thanks for being here. Appreciate the chatting as well. It's always nice when somebody chats with me, so it's not just me yammering on. So appreciate it. I don't know that we're going to get a whole lot more out of the edges of this. It needs some narrowband filter and some more exposure time. Can't wait to get that new Canon lens working. That will be fun. That will be fun. Both broadband and narrowband. Looking forward to that. Yeah, there's 10 minutes. And you can definitely see there's stuff on the outside here, but I can push the stretch to ridiculous levels to try and get it to show on the live stream, but yeah, which just completely blows the core out, of course. But there is actually a lot more out here. It just requires a lot more exposure time and preferably some filters to cut back on the star glare, which would really make it pop out nice. So, in fact, I think one thing I'm going to do, my emission nebula, do I have 1499 in here? Yes, I have 1499 in here, but I don't have this one. So let's add this object. Save and close. Yeah, so that'll be in there now. Oh, somewhere. 1491. Cool. Well, hopefully that got added in. I'll have to remember this one, because it definitely is one to look at. I mean, there's a lot more to it, but it's just so faint that it's going to take some filters and some serious exposure time to bring it out. But broadband with no filters at all, that's what we were able to get. The wispy stuff on the outside there you can see, but it blows out the core. And then if we bring the stretch back to something reasonable, the core isn't so blown out. Yeah, so you can see the core is... Oh, wrong button. Hate it when I push the wrong button. Definitely see the core is there. I got it look like a little three-toed foot there, so I think that's what it means by the fossil. I assume that's what it means, but I don't know. I make it up. So, okay. So there's the fossil footprint nebula, and a new target for me to look at when I do broadband next. Okay, NGC 2487. NGC 2487. Oof. That's still way, way too low for me. That's just barely up off the horizon. Now, the luck is I do have a pretty low northeastern horizon, but that's still way too low. So we're going to have to come back to that one. Jones 1. Planetary nebula, huh? Well, what does Stellarium know what Jones... Jones Emberson 1, I think that's right. A planetary nebula. This may be also too low. The thing about planetary nebula... Well, planetary nebula usually can be... Where is... I think we're going to have to come back to these two. So what I think I want to do is we'll go do a couple other things, more bright, pretty things, and we'll come back to do these two in a little bit. We'll let things rise a bit. Do Flaming Star. Flaming Star is a fun one. Am I ready to move? Did I know I'm not ready to move? Okay. We'll do Flaming Star. Although the Flaming Star is another one that's very faint. It's another good broadband target. The surface brightness is pretty darn low. Well, we'll give it a shot. I did this broadband the other night. Narrowband, excuse me, the other night. And it's pretty sweet target when you're using filters. But like the California Nebula and the nebula we just looked at there, Fossil Footprint Nebula, it's very faint if you're trying to do it narrowband, broadband. So we'll just fart around and do a couple other things while we wait for those other targets to rise for a bit. Alright, and start imaging. And while you're doing that, let's synchronize you on that. Okay, and you will start collecting on the Flaming Star. How's our guiding doing? 1.17. That's pretty darn good for an AVX. So not complaining there. Time for a drink. Okay. Let's see how Flaming Star is broadband. I forget. Yeah, faint. That's what I was afraid of. Right. Pop a little color balance. Bring that into play. Yeah. Well, we'll be able to see some stuff. It's not going to be real strong, but we'll be able to see some stuff. And it'll be colorful. It's a combination reflection and emission nebula. So it's got the blue of the reflection nebula, where it's reflecting the light of these big powerful stars that are right near it. And it's got the red, which is emission nebula, so where it's actually emitting its own light. Usually excited by the star's energy, but some form of radiation from the stars other than visible light is actually exciting them, exciting the hydrogen here and making it look red. So it's pretty nice. It's pretty nice narrowband, using a narrowband filters, which again will knock back 98% of the stars in the starlight. But because the reflection nebula is pretty much 100% starlight, it knocks back 98% of the blue. So when you look at it narrowband, all you see is the red parts, mostly. And so broadband, it actually looks more colorful. You've got a little bit more variation in the color with the blue and the red. But with the narrowband filters, it really cuts the stars way back and makes the red nebulosity pop out really strong. So a little bit of a trade-off there. Time for me to get up and stretch my legs. Okay. Looks like it's come in a little bit. Push the stretch now. And we can pop out a little more. Colors are balanced. Yeah, that makes it pop out kind of nice. Flaming Star Nebula. What else we got in this area? Certainly the Pleiades is nice. The Fly Nebula. Huh. While we're here, why not? The Fly Nebula. Shouldn't need to do a plate solve on this one. Oh yeah, there it is right there. I think I have shot this one recently. It's pretty small, seems to me. Seems to me it's pretty small. Well, I guess it depends on how much of it we can see. How much of it can we make pop out? Is it reflection? Bipolar nebula? Bipolar. Does that mean it's manic depressive? Bipolar. Not sure what bipolar nebula means. Let's look it up, right? NGC 1931. NGC 1931. It's an emission and reflection nebula, so I guess that's what they mean by bipolar. The nebula has been referred to as a miniature version of the Orion Nebula, as it shares some of the same characteristics. It's a mixed emission-reflection nebula and contains a smaller version of the trapezium in its hot young star cluster centered in the emission portion of the nebula. The entire cluster nebula complex is only about 3 arc minutes in size. The distance from Earth is estimated at about 7,000 light years. So similar to the Orion Nebula, but the Orion Nebula is a lot closer to us. And so, oops. Maybe back off a little bit on the stretch until we have a few more subs in to cut down the noise a little bit. Just a little guy. Guess that's what it's called, Fly Nebula. this guy's cooking. Huh. Some nice nebulous spots up here. What do we got up here? 1624. Very rich, dense star field. Magnitude 12, surface brightness 15. Yeah, I think we'll pass on that. Reflection nebula 9 and 12.3. That one we could try. No picture in Stellarium of that. But if it really is Mag 9 with a surface brightness of 12, we should be able to see that. Should be able to see it. Well, we probably won't get a whole lot more out of the Fly Nebula. So this one looked interesting. Let's try that one. On that. Probably gotta be close enough. LPN 785. So supposedly a reflection nebula. Stellarium doesn't have a picture of it. Let's see if we can get a picture of it. Moment of truth. Oh yeah, we got a little something something. A little blacks are clipped, so I gotta move my black line here. Come on, you. Come on. Yeah, we definitely got a little something there. A little bit of a wispy trail going on. I think next we'll do a big spectacular one. We'll do the Pleiades next, which is always a fun one. This one actually looks fairly comet-like. Surprised this isn't in someone's not a comet list. You know, this is the kind of thing Charles Messier would have been adding to his list, because it looks like a comet, but it isn't. let's move to something a little more exciting. Let's move to our Pleiades. Let's maybe get that one. All right. That's interesting, but not very big and not very colorful, at least not in my camera, so let's go to something that will be a lot more colorful and bright and shiny. Let's make sure we got in on the right. And on the right star. Yeah, there we go. Okay. This one is definitely going to be bigger and brighter and shinier, no doubt about that. Won't be no wispy little nebulosity here. There'll be quite a bit. And this is only, I think, about 4,000 light years away from us, I think. What does this say? Distance... Oh, I'm sorry, 400 light years away. That's right, this is a very... I think this is one of the closest clusters to us. This is going to be completely blown out when it does pop in. Oh, no, it's actually not too bad. Well, it's actually pretty close. Color balance, pull it back in. Back off the stretch a little just to make it a little less noisy. But it's going to look pretty good. Be able to crank up on the stretch once it once we get a few more subs in, it gets a little less grainy. But this is a group of hot young stars that are basically moving through an area that has a gas-rich area. And so they're basically, as a reflection nebula, they're lighting up the surrounding gases and dust that this group of stars is traveling through. A few hundred light years away from us. Pretty much next door compared to a lot of the stuff we've been seeing tonight. temperature's dropping now. Time to stretch the legs again and get the blood back in my feet. always a fun one. Give it even a couple extra minutes to clean up a little more. But really bright stars and pretty blue nebulosity. Always a crowd pleaser. Continues to cook. Well, we can try and see if we can see Uranus. That would be fun. A magnitude 1 with a surface brightness of 11. 1.2. Definitely a bright little cluster in the sky. No doubt about that. Definitely a bright little cluster in the sky, no doubt. Go to. I very rarely do planets. I don't. My little imaging newt is not set up to do planets. Usually, when you do planets, you want really high magnification, and Scott was talking about his refractor. Refractors are much better off doing for doing planets. They're higher focal length, slower focal ratio, better corrected. Higher magnifications. They're just really good for doing planetary work, and it's okay to have a much focally slower scope because planets are very bright objects, and so the slower focal ratios clean up the incoming photons better, and it just makes for a better scope to do that kind of work. So with my little 6-inch imaging newt, which is really good at collecting light from faint fuzzies quickly and putting it all together, doesn't do so well with the planets. But for something like Neptune and Uranus, and ones that are way out there, they're really pretty much only blue dots anyway, so I'll let this one last sub finish, and then we'll go take a quick look at Uranus. Pretty. Okay. Goodbye, Seven Sisters. And let's go to Uranus. No. That ain't it. Uranus, please. Thank you. That's probably our blue dot right there. I'm not even sure how long to do the exposure for. I guess we'll just do the standard 60 seconds and see what happens. Probably means the planet will be blown out, but well, we'll see. Let's see what we can see here. Yeah, that's got to be it. Yeah, that's got to be it right there. These two, and then it curves in. Those two, and curves in. And 90 degrees out is this one. Yep. Well, it's way too blown out. So, let's try dropping the exposure time way down so it's not so blown out. See, again, my scope is really good at collecting faint things and making them much brighter. So for things that are already bright, even this is still going to be blown out. For things that are already bright, it it doesn't do so good. Alright, let's drop it down a whole bunch more. Clear this out. This is going to need to have the black level put all the way over. Yeah, even at small, yeah, see, to do planets, typically you need really short exposure times. So, yeah. To get this down to a blue dot would require, in fact, what we can probably do is just turn off live stacking entirely. Oh, I wonder if we're actually seeing any of its moons. Well, actually I'm seeing 1, 2, 3, 4, which may be these 4. So I think these are 4 of its moons. At least 3. This might be Oberon, this might be reversed. Well, let's pick up the exposure to 15 seconds. And so it'll blow out the planet more, but we might see more of the moons. Yeah, see, and there's the other one over here. So that one is Ariel. Ariel is over there, and this is Miranda and Umbriel here. And then I'm not sure. I don't know if we're reversed and this is Oberon. Titania might be that one there. So anyway, we're seeing at least 2 or 3 of the moons. Oh, and there's a lot more of the ones in there, but we're not going to see those. But it looks like there's this triangle of moons here, and then this is a star. That is actually a star there. But of this triangle of moons here, and then we've got these 2 outliers. I'm not sure. See, this is a star here. I'm not sure. Don't know. Interesting, though. We're definitely picking up some of Uranus's moons. Let's go to 20 seconds. See if we can pick up a little bit more. Uranus is the 7th planet, a name reference to the Greek god of the sky, Uranus, who according to Greek mythology was the great-grandfather of Ares, grandfather of Zeus, Jupiter, and father of Cronus, Saturn. It has the 3rd largest planetary radius and 4th largest planetary mass in the solar system. It's similar in composition to Neptune, and both have bulk chemical compositions which differ from that of the larger gas giants Jupiter and Saturn. For this reason, scientists often classify Uranus and Neptune as ice giants to distinguish them from the other giant planets. As with gas giants, ice giants also lack a well-defined solid surface. Uranus's atmosphere is similar to Jupiter and Saturn's in its primary composition of hydrogen and helium, but it contains more ices, such as water, ammonia, and methane, along with traces of other hydrocarbons. It has the coldest planetary atmosphere in the solar system, with a minimum temperature of negative 224 degrees C, or negative 371 degrees Fahrenheit. It has a complex layered cloud structure with water thought to make up the lowest clouds, and methane the uppermost layer of clouds. The interior of Uranus is mainly composed of ices and rock. Like the other gas giant planets, Uranus has a ring system, a magnetosphere, and numerous moons. It's unique in that the axis of rotation of the planet is tilted sideways, nearly onto the plane of its solar orbit. Its north and south poles therefore lie where most other planets have their equators. Its wind speeds can reach 560 miles per hour. That's a breezy day. That's a breeze. Let's see if we can go to one of our objects yet. Was it Jones 1? I don't remember which one. I don't remember which one was close to the... Yeah. Let's see if we can get this one now. The Headphone Nebula. Okay. Let's get to our next target. Settings. See you later, Uranus. Thanks for the fun. Look at you out there. Okay. The Headphone Nebula. That's interesting. Yeah, that should be in a pretty good spot for us now. All right. Let's see if we can. You're going to need me to go to bigger, more exposure. Yeah, you want more exposure. Okay. Try that one. That'll give you more stars and more noise to play with. There we go. Doing that, let's synchronize on you. we should see it. It doesn't look terribly small. What is the surface brightness? Oh my goodness. Mag 17 with a surface brightness of almost 21. Okay, I take it back. We might not see much. Is it? It's a planetary. It looks like it's a fairly decent size, but oof, Mag 20 for surface brightness? Mag 17, Mag 20? Yeah, that's definitely pushing the envelope. So, we'll see. This may take more exposure time than I've we could even toy with going to bigger exposures. Let's see what we can see, if anything, here. Oh, yes. We were just on some very different things, so... let's do a color balance. Get it in the line here. Oh, I'm definitely getting something. There's definitely something there. It is very faint. It is very faint. It's there, but it's faint. It's there, but it's faint, boy. I can see why they call it Headphones Galaxy, though. Or Headphones Nebula. Definitely the headphones and the band over the top. It is very, very faint. In fact, I might... in fact, you guys are going to have a really hard time seeing this without me stretching the crap out of it, because it is super faint. So, what I may do, actually, is I may actually switch to a 3-minute exposure. The star field is not too dense here, so the star shouldn't get too blown out if I go to 3 minutes. But it is just a really faint sucker. I don't know. Maybe you can see it okay. I can get a few subs stacked on this and get the histogram right. We might be able to just get it might be able to get it to jump out a little bit more. Guess Mag 17 is within my reach in this thing. I've seen galaxies down as low as Mag 19 or 20, so yeah, let's see what happens. Might be able to make this after, with 10 subs, we might be able to get it cleaned up enough to have some contrast to have it pop out a little more. Right now I just got to have it really grainy, really stretched to make it show. But as we get more subs in, it might come on, grab. It might just clean up enough to show. But I think what I might do after this is actually experiment with trying some 3-minute subs on it, see what happens. Mag mag 17 and surface brightness of 20. That's a pretty dim object. Well, we'll give this a few minutes and see what happens. Okay, well, we've got 11 minutes on it. Probably stretch it a bit more for the broadcast, but makes it a bit grainy, but I think you can probably see it okay. Yeah, definitely there. Starts making the background a little noisy and grainy, but there's definitely the headphone nebula. I can see why it says that. Does this have an NGC? No, it doesn't. Is there any sort of distance? No. Nope. Well, it's definitely there. We don't get it real strong. I could try switching to 3-minute exposures just to see what we get, just as an experiment. But, you might do that just for the heck of it. But we're getting quite a light wash in here. I wonder if I'm picking up some stray light from somewhere. I think I'll put the hood over it, and then we'll start. And put the light shield over it. Okay, so now let's turn off the live stack, and we'll load my 3-minute configuration here, and which will need the flats from tonight to be installed. Should be good to go, and so what we'll do is we'll try and see what 3 minutes of exposure does on it. See if that makes it any more interesting to see. Normally I don't like doing exposures that long on my YouTube live streams because it is a while to wait. 60 seconds I think is about what most people are wanting to wait, so does he have any sort of... There's a planetary, a couple of observations, and an observation for 16, 18-inch scopes, and photo are in the NSOG Volume 1. So he doesn't really have... some images that are hard to see. Visual search, I don't know what that means. Pegasus, okay, well. Yeah, not sure what that gains us, if anything. So... wonder how high 2487 is. Wonder if we're going to see that one tonight. I think that one's still probably pretty low. But let's see while we're waiting. 2487. Oh, low. Oh, yeah, you're still pretty darn low. You're well under Castor and Pollux, which I can't even see yet. Yeah, you're way lower than Orion, which I'm just barely starting to be able to see. So let's see if Castor Pollux risen yet. I'll have to take a walk to see this, but... Yeah, they're looking like a no. It's looking like it's going to be something that's not going to be in my line of sight for at least another half hour. And oh, did I forget? Oh my gosh, I forgot to start the stack. Okay, so we got another 3 minutes to wait. Dang it. Unbelievable, I forgot to start the stack. Okay, so now we get to start... Okay, but this is not doing... Well, okay. No, I see what's happening here. Alright. So this is going to go to 60 seconds, so we'll get to see something for a little bit here. And then... and then we'll try 3 minutes. So, anyway, it's going to be a little bit of a wait. Yeah, so we know we're already well centered on it. So there it is there at 1 minute. So now we'll start taking 3 minute subs of it. And we'll see what a 3 minute sub will bring in, if anything. So now got to vamp for another 2.5 minutes. I think this is just going to be too low. Well, who knows? If we leave it on the headphone nebula for a while, I could just do that, go inside for a little bit, leave it on the headphone nebula, see what a few 3 minute subs do, and by then maybe we can get to 2487. I don't know. Another Web Society Galaxy of the Month for December. Don't know. Well, let's see how blown out things get, if at all, with a 3 minute sub. I don't usually do 3 minute subs broadband. Definitely do them narrowband, because with those restrictive filters you're getting a lot less light. But broadband I don't usually do 3 minute subs. So this may just prove to be a bright background. It's pretty dark. I mean, this is pointing kind of northeast for me, and the Vegas Light Dome is to the east, and Pahrump, actually the nearest town to us, is to the northeast. This is kind of shooting between the two, but I think it's high enough. It's probably about good 25 to 30 degrees up, so it should be probably pretty good. But we'll have to see. 20 seconds to the first sub coming in, which means I need to clear this one out to make room for it. Alright, moment of truth. Boom! Because our histogram is now completely wackadoodle. Alright, well there's the first 3-minute sub. Guess it remains to be seen whether a couple of these will be better than the ones we did with on 1 minute or not. I guess I should have taken a picture of the 1 minute subs, but oh well. We'll just have to be the judge. The background is not too bad on this, so in fact I should probably stretch this a bit more so you guys can see it a bit better. Still there. Only one sub, it's going to be pretty grainy, but at least it'll be visible. But even with the light shroud on, I'm still getting more of a light thing down here. We're pointing kind of over a building, so maybe there's some sort of light reflection. Some light coming off the building somehow. Yeah, there probably is some light coming off the building somehow. So, well, anyway. Like I said, I don't normally shoot broadband at 3 minutes. These things tend to get a bit blown out, but you know, we'll see. Less than a minute now to the next sub. Alright, second sub incoming. This should darken the background a bit. Yeah, that always makes a nice difference. Knocks the noise down. So what I think I'm going to do is refill my water, stretch my legs a little bit, let this thing cook for a few minutes, and when I go warm up a little bit, I'll come back in a few minutes and see where it's gotten to. So, be back in a few. Alright, well, I don't know, does it look like it might be a little bit better on the background? That over there a little bit. Let's see how that comes out on the broadcast. Blacks are a little clipped at the moment. Yeah, I don't know that it's substantially better. We're already at more time anyway, so I don't know that it's substantially better. I often experiment with shorter exposures versus longer exposures, and as long as the integration time is about, the overall integration time is about the same, I don't find there to be a terribly significant difference. But I don't know, that's just me, I guess. But that's just in my experiments, it has not proven to be really all that worth it, quite frankly. And I think this gradient, this light gradient, may just be the light dome from Vegas, because we are pretty, we're about 30 degrees up in the northeastern sky, so I think this is probably just light pollution. Well, we'll do one more, because we're only 30 seconds away from the 5th sub. We'll do the 5th sub and call it good. We'll do the last sub and call it good. And then I don't think we're going to be able to see the last object. It still looks too low to me. Yeah, that actually darkened things down a bit more. So perhaps with more time, which is more time than I want to invest in this one, but perhaps with more time it might actually pop out a little better. I'll try doing one more. Come on. Stretch on it. Really stretch it aggressively. Yeah, I don't know. This is remarkably better than the than what I tried to do. Than what we got with the 1 minute. But yeah, it's definitely an interesting planetary nebula. A fun one to do. But I think we're done with that. Let's see if we can see the last item. How was our guiding on that, by the way? Ooh. Our guiding was really not good. Might have to watch that. Okay. Let's go try and do our last object, which is 2487. I think I already have that picked off here. I'll try and slew to it. Let's see where the scope ends up pointing, because I think it's going to be just too low. Yeah, it's just too low. I'm pointing right into the side of a shed. So that's just going to be too low. So I think what I'm going to do is call it a night. So thanks everybody for being here. Thanks for sticking with me. We got all but the very last object. Maybe later in the month or early next month I can do that when it's, or actually anytime in the next few months when it should be a lot higher in the sky. But it's just a little bit too low for us here tonight. So anyway, thanks everybody for being here. Yeah, see, all we're getting is this would be a shed. So we're just going to call it a night. But thanks everybody for being here. Really appreciate it. And we'll see you next time.